In this presentation, we're going to look at the complement rule as part of our series of presentations related to the normal distribution. Now, it is a very simple rule for working with all types of probability distributions. There is a variant for the continuous distribution family, but what we're going to do is look at the type for the continuous probability distributions only. So this applies to the normal distribution, but it actually applies to other continuous probability distributions as well, such as the exponential. So an important matter to pick up on first is that, remember, for continuous distributions, the probability of an exact value is extremely small. For example, the probability that you're exactly 1.8 meters is extremely small. You might be a centimeter out or a millimeter out or 1/10 of a millimeter out. So just remember that for continuous distributions, the probability of an exact value is extremely small, such that we can treat it as zero. This little wavy equal signs here means approximately equal to zero. Okay, so it's approximately equal to rather than equal to. And so therefore we can neglect the equality components in expressions such as this. So the probability of x less than or equal to k and the probability of x greater than or equal to k. The equality component is this little horizontal line here. And in some other cases it's sort of parallel to one of the bars there. But it sort of says less than or equal to or greater than or equal to. Essentially what we're going to do is just neglect that part of the expression. So what we have here is we have two expressions, and essentially what we're going to do is treat them as the complements of each other. So this expression here and this expression here. So they are complementary events. Now, so how do we compute the probability of complementary event? Simply subtract the probability of the event from 1. So probability of x less than or equal to k is equal to 1 minus the probability of x greater than or equal to k, and vice versa. The probability of x greater than or equal to k equals 1 minus the probability of x less than or equal to k. So it's one of these two here. They're actually directly equivalent to each other. You just have to rework one of them to find the other. Okay, let's look at an example. So I've written the expressions there again, those two formulas there. So we have two events here. Probability of x less than or equal to 100. The probability of that is 0.65. So what is the probability of it being greater than or equal to 100? Well, the answer is simply 1 minus 0.65. This is 0.35. Likewise, the probability of y greater than or equal to 80 is 40%. What is the probability of y less than or equal to 80? That is 60%, 0.60. So that ends our presentation.